You know, massive ships are crisscrossing our oceans right now, carrying literally everything, your phone, your food, you name it. But to keep these giants moving, they need to be cleaned. And that cleaning process? Well, it has a really dirty secret, a secret with a massive environmental price tag. So let's get into this hidden story.
I mean, how do you clean a 100,000-ton ship? It's a huge challenge, right? We're talking about a surface area the size of several football fields, just caked in barnacles, algae, all kinds of marine life. And this isn't just about keeping the ship looking pretty. No, it's all about efficiency.
Yeah, that whole buildup has a name. It's called biofouling. And it's a real problem. Think of it like a giant brake on the ship, just constantly dragging it down. That forces the engines to work way harder, burning a ton more fuel. So you can see why for both money and just, getting from A to B, all that marine life, it's gotta go. And the way they get it off, it's pretty aggressive.
The main method is called hydroblasting, and you can basically just imagine a power washer on steroids. I mean, these things are blasting away not just all that marine life, but also layers and layers of old paint. And all of this creates a huge amount of wastewater. The technical term is effluent. And this is where the story gets dark, because that runoff isn't just water and bits of barnacles. It's a straight-up toxic soup.
All right, so we've established there's a problem. And for the longest time, this toxic soup has just been flowing into our oceans, mostly unregulated. But then, a team of scientists decided to take a closer look. They basically treated the runoff from one single ship cleaning like a chemical crime scene.
So what they did was, these researchers over in South Korea, they took a sample of this hydroblasting water, and they had one big question on their minds. Just how dangerous is this stuff really? What's in it, and what does it do to actual marine life?
And to get their answer, they used something called zebrafish embryos. Now, these are kind of a go-to for toxicity testing in science. Why? Because these tiny little embryos are super sensitive to pollutants. They're basically the perfect canary in the coal mine to see if water is toxic.
And the results? Well, they were pretty shocking. Take a look. In the control group, with clean water, pretty much all the embryos were fine, 0% mortality. But when they were exposed to the hydroblasting water, a staggering 89% of them died. Let me say that again, 89%. This stuff wasn't just a little bit harmful, it was flat out deadly.
Okay, so an 89% death rate is a massive red flag. The water is clearly toxic. But why? What exactly is in this mixture that's causing so much damage? It was time for some chemical detective work.
To do this, they used a really clever technique called effect-directed analysis, or EDA. And the easiest way to picture it is like a forensic chemical lineup. Seriously, they take this whole toxic soup, they break it down into its individual chemical parts, and then they test each part separately to see which ones are the real killers. It lets them pinpoint the absolute worst offenders in the mix.
And what they found? Well, it wasn't just one bad guy. It was a whole cocktail of nasty chemicals. You've got plasticizers in there, things that make paint flexible. You've got biocides and herbicides, which are literally designed to kill living things. Solvents, glycols, paint additives, the whole shebang.
And let's zoom in on just a few of the prime suspects they rounded up. You've got things like do-butyl phthalate. That's a plasticizer that's also a known endocrine disruptor, which is really bad news. Then there's trilopyrrole. This is an anti-fouling biocide, which means its entire job, its purpose, is to be toxic to marine life to keep it off the ship. So you see, these aren't just some accidental contaminants. They are key ingredients being blasted right into the ocean.
So the results from just this one ship are pretty terrifying, right? But here's the thing. That's just one ship. What happens when you start to think about the bigger picture? When you scale this up from one cleaning to the entire global fleet?
Okay, let's start with the baseline numbers from this one ship. Just cleaning this one vessel created, get this, 26,201 liters of that toxic wastewater. To put that in perspective, that's more than enough to fill a typical backyard swimming pool. And that's just the total volume of the water. When they looked at just one of those toxic chemicals we talked about, 1,5-naphthalene-diamine, they found over 121 grams of it were released. Now, that might not sound like a lot, but remember, this is a potent chemical, and that's just from one cleaning of one ship.
So here's where it gets really big. Ships usually get this kind of deep clean in a dry dock about every 5 years. So, what happens when you take those numbers we just saw and you multiply them by the tens of thousands of huge ships all over the world all on this same cleaning schedule?
Well, the researchers ran the numbers, and their estimate, which they say is a conservative one, is just staggering. Every single year, more than 16 tons of these specific toxic chemicals are being blasted into our oceans. Just from this one process, 16 tons.
When you hear a number like that, it completely changes how you see things, doesn't it? Suddenly, hydroblasting isn't just some boring routine maintenance. It's a massive and largely ignored source of global pollution. And that's a serious call for change.
So, what's the verdict from all this scientific detective work? It's pretty clear-cut. First, the runoff from hydroblasting is incredibly toxic to marine life. Second, this isn't a local problem. The scale is global. And maybe most importantly, in a lot of countries, including where this study happened, there just aren't specific regulations for this kind of waste. It just gets washed away.
And if you need any more proof, just listen to this quote directly from the study. They said the concentration of that one chemical, do-butyl phthalate, was higher than the reported lethal concentration for several aquatic organisms. In plain English, that means the amount of this one chemical in the water was already enough to be deadly. This isn't some far-off theoretical risk. It's a direct, immediate threat.
So really, the bottom line is this. A routine maintenance task, something that's totally essential for global shipping to even work, is also actively poisoning our oceans, year after year.
And that leaves all of us with a really big question, doesn't it? We absolutely depend on these ships. They're the backbone of global trade. But now that we know the hidden cost of keeping them clean, can we find a better, cleaner way to do it? Can we innovate and enforce rules that protect our oceans? Because it seems like the health of our entire marine world might just depend on it.